All right, so in the previous video, we looked at factoring perfect square trinomials using the patterns that we learned a couple videos ago. What we're going to do today is we're going to use those patterns to help us solve equations. Um, so let's take a look at example number 4. Uh, we have x squared plus 2/3 x plus 1/9 equals 0. Now, in this case, because we're solving an equation, what I'd like to do is try to eliminate the fractional coefficient of the linear term and then also the fraction that we have for our constant value. So what I'm going to do is multiply both sides of the equation by a common denominator. In this case, that would be 9. So we grab the pen first here. All right, so we're going to multiply both sides by 9. And that's going to give us 9x squared plus 2/3 times 9 is 6, so 6x. And then 1/9 times 9 is just going to be 1, and that equals 0. So that gives us a much nicer equation to work with. Now, what I'm going to do is check to see if the left-hand side of this equation is a perfect square trinomial. If it is, great. If it's not, I'm going to try to factor it using the area model like I normally would. So the first term, is that a perfect square? Is 9x squared a perfect square? It is. If you take the square root of 9, you get 3. Take the square root of x squared, you get x. So a in this case is 3. The constant term, is that a perfect square? Is the square root of 1 a perfect square? Yeah, that equals 1. So in this case, b equals 1. And now we're looking to see if this middle term, 6x, is 2 times, I'm sorry, this should be 3x right here, is 2 times ab. So 2 times 3x times 1 is 6x. So this is a perfect square trinomial, which means the left-hand side of the equation factors to 3x plus 1 all squared, and that's equal to 0. All right, so now the question becomes, well, how do we approach solving this equation? Well, we're trying to isolate x. So we're going to try to undo the operations that are being performed on x here. So the first one we have to do is undo squaring the quantity. So we're going to take the square root of both sides. And that's going to leave us with 3x plus 1 equals. Now, we're going to have to put a plus or minus in front of that. Plus or minus 0. Anytime you take the square root of both sides, you want to get in the habit of putting a plus or minus in front of that. And I'm going to give you kind of a brief sidebar as to why that is the case. If you look at this equation right here, x squared equals 25. There are two solutions to this equation. You could square 5 and get 25, or you could square -5 and get 25. So the solution to this, when we take the square root of both sides, is x equals plus or minus the square root of 25, which is x equals plus or minus 5. Okay, so that's the rationale for that. Now, in these particular cases, it's not going to matter all that much because we're taking the square root of 0. But again, it's something to get in the habit of doing. So I'm going to write this now as 3x plus 1 equals 0 because those are the same values. Subtract 1 from both sides. We get 3x equals -1. Divide both sides by 3. We get x equals -1/3. Now, this is kind of interesting because the overwhelming majority of the quadratic equations that we've solved that have solutions have had two solutions, which makes sense if you think back to the graphs of these functions. They're parabolic in nature, and they intersect the x-axis twice in a lot of cases. When you're dealing with a quadratic function that's a perfect square trinomial, what's going to end up happening is that the graph is only going to hit the x-axis one time. It's going to hit the x-axis at its vertex, and that's why we're only getting one solution here. I would encourage you to go and graph x squared plus 2/3 x plus 1/9 as a function in Desmos, and what you're going to see is that the graph is going to intersect the x-axis only at -1/3 at its vertex. Okay, so that's something that you can go and check out. Oops. All right, let's do this next example. X squared minus 14x equals -49. So in this case, the quadratic function itself, or quadratic expression itself is not set equal to 0, so I'm going to move 49 over, and we're going to get x squared minus 14x plus 49. I had to add 49 to both sides, equals 0. So again, we're going to check and see if this is a perfect square trinomial. The first term, is that a perfect square? Yeah, the square root of x squared, in this case, will be x. Square root of 49 is 7. So b is going to equal 7. And then again, we're just looking at the absolute value of this middle term. So 14x, is that 2ab? So 2 times x times 7 is 14x. So this is a perfect square trinomial. So this will factor to x minus 7 quantity squared equals 0, because the linear term is negative and the constant term is positive on our original expression. So again, we're going to use the same exact technique as we did before. Square root both sides. X minus 7 equals technically plus or minus 0, but again, that's just really 0. And then we're going to add 7 to both sides, and we're going to get x equals 7. All right, so that's going to do it for this one. If you do have any questions or concerns, let me know. Send me an email, message me through Google Classroom. Now you can go and practice this and submit your evidence of learning through Google Classroom. All right, so thanks, and we will see you in the next video.